first of all, let's talk about what the formula is here. So if I am finding the arc length, then that formula is going to be the angle measure over 360 times 2 pi r. Okay? So they've given me the arc length, which is 3 pi over 2, and I'm going to write that 3/2 pi. It just makes it easier when I start manipulating this fractions. 3/2 pi is the same thing as 3 pi over 2. Equals, they gave me the angle measure, which is 45 over 360 times 2 pi r. All right, I can reduce these. What can reduce here? So you can actually reduce the 45 and the 360 to 1 over 8. And then you have this 2 over 1 that you're multiplying by. So you can actually cancel there as well. The 2 can cancel with the 8, 1 and 4. So I did all of this, 45 over 360 times 2 over 1. I reduced this fraction to 1 over 8 times 2 over 1. And then I reduced this right here to 1 over 4. So all that fraction work there, I have on the left-hand side, I haven't touched that yet. And on the right-hand side, I actually have 1/4 pi r. Okay? Now, when you have a pi on both sides, those are going to cancel. Here's what happens. If I divide both sides by pi, so I'm going to divide by pi here and divide by pi here, then you can see that pi will cancel there and pi will cancel there. So anytime you're multiplying by pi or anything on both sides, it will cancel out of your equation. And so now I'm left with 3/2 over here and 1/4 times r over here. How do I divide out that fraction? What do I need to multiply by when you're dividing by a fraction? Multiply by the reciprocal. What's the reciprocal of 1/4? 4 over 1, right? So 4 over 1. And it cancels on this side, and I need to multiply this side by 4 over 1. I can cross cancel. What can I cross cancel here? The 2 and the 4. That becomes 1 and 2. So r is going to equal 2 times 3. My original was in meters, so that is why it is 6 meters. So we have talked about central angles. These are angles that actually have a vertex at the center of the circle. A vertex at the center of the circle. That is a central angle. And in the prior sections, we have seen that the measure of the arc, not the length, but the measure of the arc was equal to the measure of the central angle that made it up. And so central angles specifically have a vertex at the center of the circle. Now we are going to be looking at inscribed angles. Inscribed angles. So let's first look at the definition of an inscribed angle. An inscribed angle is an angle whose vertex is a point on the circle. So the vertex for an inscribed angle is a point on the circle, where a central angle was the center of the circle. The sides are chords of the circle. So the sides of this guy are chords of the circle. So if you'll notice, V is the vertex of the angle, and it is on the circle. VU is a side, and it is a chord. VW is a side of the angle, and it is a chord. So the angle, the inscribed angle here is the angle UVW. That is an inscribed angle. Notice the difference between that and the central angle. The central angle has the vertex at K, and then the sides of a central angle are radii of the circle. And so the central angle here would be angle MKL. Okay? So that's the difference between an inscribed angle and a central angle. Central actually has a vertex at the center, which is why it's called central. Question.
So we're just like writing down.
So case 1, the inscribed angle can actually go through the diameter here. All right, so the center is on the inscribed angle. You'll notice that this inscribed angle has one of its sides that is a diameter. That can happen. You can have it where the center of the circle is inside your angle. Or you can have it where the center of the circle is on the exterior of the angle. But these are all considered inscribed angles. One point, the vertex is on the side, and the other two are made up by chords. But all three of these cases create inscribed angles. So let's look at a theorem regarding inscribed angles. Top of page 371. The measure of an inscribed angle is 1/2 the measure of the intercepted arc. Now remember, with central angles, it was the same. If your angle measure was 60 that made up the arc, then the arc angle measure was 60 degrees. They were identical. For inscribed angles, the intercepted arc is going to be twice as big as the inscribed angle that made it. All right? So let's look at that example there. Find each measure. The first one they want us to find is VYW. So we're going to start, when they want that angle, you start and follow it. V to Y to W. So V to Y to W is this angle right here. All right? Our theorem says that the measure of the inscribed angle is 1/2 of the intercepted arc. This intercepted arc is 60. So that means the inscribed angle that makes up that arc is going to be 1/2 of 60, which means that angle measure is 30 degrees. Simple? All right, let's look at the next one. The measure of arc WX. So now they're asking for the arc. Notice your notation, all right? W to X, W to X. They want this arc. Now, we don't have the inscribed angle that makes up that arc. We actually have this inscribed angle that is 55, okay? But that inscribed angle makes up this whole arc from V to X, all right? Makes up the entire arc. So if I know this piece is 55, this should be exactly 1/2 of the arc that it creates. So I can take this inscribed angle and I can double it. So this arc right here should be 55 times 2, right? I already know a piece of it. I already know this piece is 60. I'm looking for this piece, so I can just subtract it. Which means W to X, that arc, is going to be 50 degrees. So you're working off the same concept, but you may need to work around the circle. Like if you know you have a semicircle, then you know 180, and that may help you find the piece you're looking for. Or if you have pieces of the whole thing and you know it's 360, then you know your arc addition postulate tells you you can add those up. And so you're going to be using the fact that the inscribed angle is 1/2 of the arc, or that the arc is double the inscribed angle, to find other pieces. This is basically common sense here. Incongruent circles are the same circle. Inscribed angles are congruent if and only if they intercept congruent arcs. So if the angle measure is related to the arc measure, then you can assume that if the arc measures are the same for congruent circles, then the angle measures are the same because they're based off those measurements. An angle inscribed in a semicircle is a right angle. So an angle inscribed in a semicircle is a right angle. Well, how much is a semicircle? How many degrees is a semicircle? 180. So that makes sense that 1/2 of that is going to be a right angle. So some of this is common sense. Opposite angles of inscribed quadrilaterals are supplementary. So inscribed quadrilaterals have the same theorems as the other ones. So those are actually going to be supplementary, or they add up to 180. Because if it's inscribed as a rectangle, that means it has to be hitting two sides of that circle. So let's look at this. All right. Find each measure of the figure where DAB is 208. So they've given us some information on this image, and they've given us some in the instructions. They've told us that DAB is 208 degrees. That is an arc measure. So from D to A to B, all the way around, this is 208 degrees. So what does that tell us? Well, that tells us that the angle that makes up that arc should be 1/2 of that. So let's figure out what angle makes up that arc. Well, B is part of that angle. D is going to be part of that angle. And inscribed means it has to be on the side. So B to C to D is the inscribed angle that makes up the arc DAB. Does everybody see that? So DCB is the angle that makes up the arc DAB. That's what created it. So if I know the arc is 208, then this angle that makes it up should be half of that. So I'm going to take 208 divided by 2. And I know this angle that made it up is going to be 104. Does everybody see that? So even though there's extra lines, you're still looking at the angle that creates the arc. The angle that creates the arc. So that information is going to help us with the rest of this. The first thing they want to do is they want to find angle ABC. Angle A, B to C. All right? So we're going to look and see what angle that is and how does that help us. So A, B to C. If I look at that particular one, and I'm going to take away the other pieces here. I'm going to take away this so that we can look at just those. If I go A to B to C, that is right here. All right, that is right here. A to B to C. What arc does it cut? Well, it cuts this arc right here. What type of arc is that? What type of arc is ADC? It's a special type of arc. It's a semicircle, right? How much is a semicircle? 180. So the angle that makes up that semicircle should be exactly half of that. What is the measure of ABC? Exactly half of that would be 90. Remember, an angle that makes up a semicircle is 90 degrees. All right? Let's look at the next one. Let's look at the next one. They want B to D to C, and they want the angle measure. B to D to C. B to D to C. All right? So I know a little bit about this particular angle. I know that it intercepts a half, that A to D to C intercepts a half circle, right? I also know that BDC equals BAC. All right. Both angles intercept the same arc. And so BAC intercepts this arc. BDC intercepts that arc. So I know they equal each other because we just had the proof that they equal each other. So I know that these two equal each other. Because they both intercept this arc right here. All right. So then that means that I can take this 68 degrees, which is right here, and I can subtract it from the 90 that I know this guy is, and it should be equal because they should be complementary. So I can take this and subtract the 68, and I will get my 22. And so I know that this measure and this measure actually are going to be 22 because they're going to be the same exact measurement. They intercept the same arc. All right, let's look at one more. One more, and then we're going to do some. All right, let's look at the last one, D to A to B. D, A, B. All right, D, A, B. For this particular one, I'm not intercepting a half circle because it does not go through the center of it. But I do know it's 1/2 the measure of what it is intercepting. So I do know that if I have, actually I want the arc, not the angle. I drew it wrong. If I know what the measure of the angle is, then I can use the arc to help me solve it. Let me get rid of those. All right. So I know that it's going to be 1/2 the measure of what it creates. So I know it's going to be 1/2 the measure of this guy right here. All right. if I know that the opposite sides are complementary or supplementary, which is what we just said, an inscribed one, this guy and this guy should be supplementary. Then if I can find the other side, then it was going to help me. So if they're supplementary, it should help me find out what I'm looking for there. And so I know that this is intercepting this angle that they gave me here, this arc. So I know this guy is 104. We already figured that out earlier, right? And then I can subtract the measure across from that, and I should get what this one is because these are supplementary. So if I know this side is 104 and I know these two are supplementary, then I can just subtract. And I will be able to get this guy because opposite angles of inscribed are supplementary. So if I can figure out what this one is, which we just did when we divided that one, I can subtract it across. A and C are supplementary, B and D are also supplementary. All right? So a lot of stuff going on when they give you one picture. You've got to be able to figure out which inscribed angle you're talking about, which arc you're talking about, and work it one at a time. So if I give you a handout, which you're going to have, you may want to use some colored pencils or something to figure out what angle you're talking about, what arc you're talking about. All right? So let's try some of these, and then we're going to do some from the handout. All right? The first thing they want to know is what type of angle. So is it inscribed angle? Is it a central angle? Then they want you to use the measurements they give you to back into the other measurements. And I'm actually just going to make you do the first 4 here. So just do 1 through 4 on page 372. Let's look at these. What type of angle is angle W? X to W to Y. What type of angle is that? Is that central or inscribed? Central, right? Central angle. All right, what about Z? What type of angle is Z? That is an inscribed angle. All right, find the measure of W and of Z if X to Y is 86. So X to Y, that's the arc measure that they have given us. That is 86. W is the central angle. We just established that. What do we know about arcs and central angles that make them up? What do we know about their angle measures? They're the same. So W here should be 86. What about the arc and the inscribed angle that made it up? What do we know about that? The inscribed angle should be what? Half of it. So what is Z here? Half. It should be half of it. It should be 43. 43. The angle is half of the arc measure for an inscribed angle. Half. All right. Look at the next one. Everybody see that? So for this one, they gave us a major arc. So they said from X to Z to Y, that is 278. But they want W and Z. W and Z actually create, for their inscribed angle and for the central angle, they actually create this arc. How do I know what that arc is? What do I do to find that first? Yeah, a whole circle is going to be 360. So to solve for this one, I'm going to say 360 minus 78, right? And what do I get there? Hopefully you get 82. All right. 82. So now I automatically know my central angle. What's my central angle if my arc's 82? It's 82, right? What's my inscribed angle at this point? Half of that. 41. All right. Central angles are the same. Inscribed angles are half. Number 1 is not an inscribed angle. Why is it not an inscribed angle? What's the problem? Yeah, where's my vertex? My vertex here is in the center. Where does my vertex need to be for an inscribed angle? On the circle itself for an inscribed angle. Let's look at the difference between that and 3. For 3, my vertex is on the circle. So they want me to name the arc that it intercepts, and they want me to name the angle. Angles are always going to be 3 points, really. I mean, you can say Q, but you need to be careful if Q were to make up more than one. So if you want to put all three, that's fine. You can also put angle Q because it only makes up one angle here. So the angle that makes it up is the RQS. The arc that makes it up is RS. Know your notation between angle and arc so that when they give you one, you know what they're talking about. One is angle, one is arc. If I look at the angle, this is the angle. And when you go out, what piece of the circle does that angle cut? That angle cuts this piece of the circle, which is the arc RS. So you're looking to see what piece of the circle it cuts when it goes through. The inscribed angle is exactly half of the arc. What did they give me here, the angle or the arc? They gave me the arc. They want the angle. So I need to take the arc and I need to cut it in half. And I will get the angle measure of 87 degrees. So go ahead and do that next one. Should not take long. All right, they gave me the arc measure. What's the angle measure? Right, I'm just going to cut it in half. 110 divided by 55. Divided by 2, rather, is 55. All right, look at the next group. All right, find the angle measure. Again, they want the angle measure, and they have given me some information, but not the exact information. So you can see this is a little bit different. On this one, they gave me 110, but they did not give me the arc that I'm looking for to help me. Does everybody see that's not the arc that is made from that angle? If I look at the angle that I'm talking about, which is this angle right here, the arc that I would need is this piece. I need that piece. They did not give it to me. They did give me enough information to find it. This particular angle goes through the diameter, which means I have a semicircle. So that means all the way around here is a semicircle. I have part of it. I need the other part. How do I find the other part? Yeah, so I'm going to say 180 minus 110, and what am I going to get there? 70. So now I know that this arc measure is 70 degrees, and now I can cut it in half to find my inscribed angle. So if I'm trying to find the angle measure of F, the measure of angle F is going to be 70 divided by 2. So go ahead and do all right, let's look at this. The angle that they want is angle X, right? They want this angle right here. This is the angle they want, which means what is going to help me is this arc. I do not have that arc, but I do have the other two pieces that make up the entire circle. So what's an entire circle? 360. And so if I want to find that arc, I can take 360 minus the rest of my circle. All right, so you're going to say 360 minus, and you do get 204 here. So what do you get when you subtract that? 156. That actually tells us this arc measure over here. I want the angle. What do I need to do to the arc measure? So the arc measure, if I want to find the angle, the arc measure is 1/2 of it. So I need to divide it by 2. All right, you need to divide it by 2. You should have gotten 78 there. 13, in this case, they gave us the angle. They want the arc. So if they want this particular arc, then we need to use this angle to find it. If I know the angle and I need the arc, I'm going to double it. So I'm going to take the 46 and I am going to multiply that by 2. All right. Take the 46 and multiply it by 2. You should get 92 there. So what's the next one? I know my angle measure is 50. I double it. What should I get for this one? 100. Okay, so on this one, again, they gave us some information, but they didn't hand it to us, right? So the first set there is like, gift wrapped. Pretty much you're just doubling or halving it, right? And so now you're building up to have a little bit more information you have to deal with. For this one, they gave us this angle measure that is 59, all right? And that's going to help us with this arc right here. But the arc that they want is this one right there, okay? So I can figure out the blue one. I can just double my 59, right? What happens when I double 59? I get what? 118, right? But I actually need this piece over here. Now, here's the deal. I have a semicircle. How do I know? The key is this goes right through my center, which means this whole entire piece over here from N to F to L is a semicircle. So then I can solve for what I'm missing by subtracting from what? 180. So I can say 180 minus the 118. And that is going to give me my answer of 62. So go ahead and do that next one. So they want this piece of the arc here. They want this piece of the circle. But they didn't give us the angle that creates it. They did give us another angle. So what is that helping us find? Well, that 63 degrees is actually helping us find this piece. So we're going to go ahead and find that piece, even though that's not what we're looking for. What is that green piece of it right down there? If that's 63, this piece is going to be 126. Why does that help us? Well, because we have the 94, and an entire circle is going to be what? 360. So if I want to find this missing piece, I can say 360 minus the 126 plus 94. And that will help you find the 140 that's left over when you subtract. All right, so for this one, they gave us an angle measure, but it is in algebraic terms. My angle measure here is 14x plus 1. My arc measure is 86. Now, what I do know is that my angle measure should be half of my arc measure. And so that's how you always want to set it up. So you're either going to set these up by saying, well, 2 times my angle equals my arc, or my angle equals half of my arc. Those are the exact same things, but you need to think about, what do I have? What am I trying to find? So in this case, I'm going to say the angle equals half of the arc, because it's going to be easier to do that than if I try to double a binomial here. So my angle is 14x plus 1, and that should equal 1/2 of my arc, which is 86. And so now I just have a basic algebra equation to solve. 14x plus 1 should equal 43. I am going to subtract my 1 over. Just solving at this point. 14x equals 43, and that is divisible. So my answer here is going to be that x, that's 42, x equals 3. Okay. All right. So go ahead and solve for 23. The variable that we're trying to find is in this angle RQN, which makes up the arc RN. All right, so it makes up this arc. They did not give us that arc, all right? They gave us the arc PN. But what you hopefully notice is RP is a diameter, which means from P to N all the way to R is 180. So the piece that I need to solve for this is going to be 180 minus 80. This right here is 100 degrees because I took 180 minus 80. So that means that when I'm solving this, my angle 9x plus 5 should equal 1/2 of the arc that it makes up, which is 100. So I have 9x plus 5 equals 50. 9x equals 45. X equals